Hello, everyone. I'm a network engineer. I am CCIE in routing switch and wireless. Now, I want to make a series of video about IT network automation. Uh, Actually, I want to share the skill about network automation I developed in the last projects. Hopefully, the skill I share can be helpful to you if you work in IT network. Uh, According to my experience, the network automation can enhance the work efficiency largely. Here, I want to say um, this video is more suitable for the people in IT network and the people working in IT network and have the foundation for programming. Of course, we all know the network automation is about programming. Okay, now we start. So this video is section 1 is network routing switch troubleshooting automation. The network topology is here. This one is a network topology I made according to the one in my last project. I just take the routing switch part and do some change to show the automation program. Here we start step by step. The network automation is about writing the script and make the computer do the task that a network engineer need to do manually. And here, I just use the Python language to do the network automation. Okay, let's go about the IT environment for automation. Yeah, of course, to run the network automation, we need to set the right IT environment. And we need Python. We need to install Python because I use Python to just to make the automation happen. And yeah, I suggest you just to run the network automation. You just choose the latest version Python and not too old one. Otherwise, it will not support the network automation. Apart from installing Python, and we need to install the NetMiko. Here, I just use NetMiko platform for the network automation. The NetMiko installation is easy. There are also a lot of videos online you can find just about installing NetMiko and some simple simple use about the NetMiko automation function. So now I will now to talk about how to install this. You can find it easily. Uh, After installing the Python and the NetMiko, and we need to make sure the PC that run the NetMiko automation function can pin all the devices in the topology here. This is a topology, and here is a PC. It's a local PC. This PC, and you have to make sure the PC can ping all the network device. I suggest you arrange a static route for each network you want to ping to. That's to say, you guarantee there's a static route between your PC and each network device in the topology. Each one network device, one exclusive static route. At least you guarantee your PC can ping all the network device. To add the static route from your PC, from the PC run automation function to a network device is easy. The command is like this: root add the destination address. This is a IP address in the network device you want to pin to, and the network mask and the next hop address. Here is just the gateway address. For example, we want to go to pin to R6, add an static route from your PC to R6, and you just add the destination address. Here is an IP address in R6, and here the next hop address is F1 slash 0. Yeah, you directly connect to it and just set the static route. Yeah, yeah. 10.2.1.1. Just like this, you set static route from your PC to each network device. After doing that, you make sure your PC can pin and telnet to all the device. All the device one. Yeah. And this is a device list for this topology. And to make sure you can telnet the devices, you can test by PuTTY or any network pin test tool. Make sure it can in the telnet. Otherwise, the automation function will not work. It can telnet. Okay, to set the telnet function in the destination device, there are a lot of video online. It's just to guarantee the SSH connection can be done from your PC to the network device you want to pin to. Yeah, there's many videos about setting the privilege. Yeah, and just to enable the SSH function, SSH connection. So I will not talk much about this. It can be done easily. Okay, after making sure your PC can ping and telnet all the function, you after making sure your PC can ping and telnet all the network devices, we can start the automation program, automation script. Okay, yeah, here the make sure the IT environment can be established well. And yeah, now we come to the network topology. Yeah, to write the troubleshooting automation program, we have to understand the traffic flow for the network. You know, the net micro automation function is written based on the understanding the network traffic flow. It just writing it just written according to the traffic flow. Here, the, in this network topology, we use the dynamic network protocol (OSPF), the IP address, subnet address in the network device router is transport or OSPF to other network device, to other router, and so the network address is mainly just a length or OSPF, and the OSPF setting here is simple, and I just set the enable the OSPF in the device's interface. Try to make it easy. For example, like you look the OSPF is successfully established with the neighboring devices. And yeah, uh, yeah, and as I say, I set the IP OSPF in the network devices interface like this. Uh, so this is about the traffic flow. The IP address is just a length OSPF, and there is no BGP. So the IP address is just translated by device by device. It's just one device learns the IP address from the devices connected to it, and just bypass the device to the next one connected to it. Just the IP address is just transport one by one. Uh, yeah, all the network protocol is IGP. There's no BGP. Uh, yeah. So to do the troubleshooting, the idea is mainly focused on OSPF. We go to see the OSPF neighbor and to make sure the OSP the one device establish the OSPF with all the uh, devices connected to it. Based on it, we get the troubleshooting idea for this network. And according to the troubleshooting idea, we can write the automation function, the automation program. Uh, yeah, I will just explain my automation program function, what it can do, and show it, run the program. Now we go to the automation code. Okay, here. I would like to share the code to you, and you hopefully you can take reference and apply it in your network project. Of course, as I say, the RS troubleshooting automation program is written based on the network traffic flow. So it is just an example. You can't just copy it and run it. You have to write your program according to the network traffic flow in your network or in your program. This is my code. It is written by Python. Python is a good language for applying the network automation. You can see it clearly. Um, uh, for the Python automation script, and you don't need to have the very solid foundation for algorithm and data structure. And you yeah uh, that's to say, you don't need to just arrange a sophisticated algorithm. You just common understand and common use for the data structure in Python, and design and arrange the sim- um, the middle level algorithm. Sorry. Yeah. It's not very easy to, it's not very difficult to write the code after knowing the network traffic flow. As you can see, it is that. I simply explain the function of this code. Okay, like the common troubleshooting. Um, the code tests the pin and the trace route. Firstly, it asks you to input the source device and the destination IP address. Just which device you want to pin to the destination address and which destination address you want to pin to. After that, I will test the pin and test the trace route. If it can pin to the destination address, will test whether the trace route is the one you want, and if the trace route change, it will find out the issue why it changed, and mm, yeah, and after that record uh, the pin result and the trace route result and the issue caused the trace route change. Write this information into different files. This is a function of this code. Now I will run the code and show its function. To run the Python code, here is a network topology. To run the Python code, we use PowerShell, Windows PowerShell. Okay, we go to the right file directory or the right file location for this code. The code is just here. This is a location. I go to Python 27. Okay, sorry. This Python code just can monitor um, the config change of all the devices in the network and just list the config change if there is. Okay, we run the code and see it is automation troubleshooting function. Um, Python technical. Okay, they ask you which device you want to do the pin test. And here, for example, we choose R7, and we want R7 to do the uh, okay, do the test to here. Okay, to a further one to here, and we have look. We go to R7, and we say we want to pin. Address here is any beside one. We can there's an IP list. We can find the CNI beside one is 198.19.7.25. The IP address is here. Okay, we pin. Okay, we pin successfully. And what is the trace route? Here. Okay. And okay, as I say, okay, now we run the code and just to see the result. And before running the code, I just clear the file, some relevant file, because the code will after the code is executed, and some information will be write into the file, and I just refresh the file to make sure it is empty, and just and see what can be written to the file after this code is executed. And after the code executed, and the trace route information will be written in this file. Now I just clear all the information, and the OSPF status information. This is a major reference for troubleshooting in this network topology. Will be written here. Now I just clear all this to make these two files are empty. Okay. Okay, we go to the program and we say it's R7. R7, it is we want to do the pin test in R7. R7 name is just Mohill. Okay, this is a name. I got for this router. And they ask me which destination address I want to pin to. Okay, see here is 198.19.7.25. Firstly, we'll just automatically check whether it can pin, and then recall if it can pin, records the trace route information. We execute the code. It will take some time, but since all the pin and trace route pin and trace route process can be done automatically, you can do something else during this time inside of just troubleshooting devices or do the pin test manually. It take you time. Oh, you can, for since everything can be done automatically, so you can run multiple code in several computers or VMware virtual machine. In this way, you can deal with multiple troubleshooting tickets. This is a big advantage of network automation. Okay, the the program is finished. So we say that we can see the pin test result is it can pin from R7 is the module to this address, and the record trace route is written into the file. I show you. This one I just declare is the empty one. Now it's just get information. Yeah, yeah. This one firstly come to the dot 9 and then dot 7 38 dot 25. Okay. Assuming there is a change. I will do some change and to make the trace route for this destination different. Mm, and to yeah, and to see the troubleshooting function for this code. Okay, now according to this, the pin from these devices to here is just go this way. But CD beside 3, CD beside 4, CD beside 1 here. But if there's some issue and the OSPF neighborhood change, or in other words, some OSPF neighborhood down, we do it manually. For example, I just close the OSPF neighborhood here. I make the OSPF neighborhood between these two devices down. And the IP address, the IP address here in this device, CD beside 1, will not be transported to CD3. And R7 will not learn the destination address from CD beside 3 because the OSPF neighborhood down. And in this way, of course, all the devices have an OSPF neighborhood, so they are for each devices they are different. There's always alternative route for the destination for one destination address. In this case, if the OSPF neighborhood down, then the destination address will not transport in this way. So it will learn this destination address in other way. Maybe the CD just transport from CD beside 1 to CD beside 2 and beside 3 to R9 and R7. But the result is, if we do this change, the trace route for the destination address will change. We do it. Okay, for example, we we close the OSPF neighborhood. We just disable the OSPF in this interface as 0/0. Okay. Yeah, as I say, the OSPF neighborhood is set inside the interface. The OSPF is set inside interface, as we can see. Now we disable this. Look, 0/0/0 done. And the destination address will not learn in this way, so the trace route will change. We have look. We pin. Okay, I can pin, and we trace route. Look, it just different. Go different. Okay, this is the trace route change. If we want to crack this, we run code to do the troubleshooting. See, we wanted pin from R7 More Hill, and the same the destination address is in beside pin 1. Let's have a look. During this time, you can do something else. Make computer do the troubleshooting work, and you can do something else. Okay, as it's show, is still successful, but the trace route change. Okay, it's done. Because the running time for this code is a little bit longer because it will just automatically go to each device, the relevant device, to see the configuration change and to find the issue. So it take some time. Take time for connecting to different network device. Okay, let's have a look. Yeah, as I say, the record, the trace route information is recorded in record root text. Okay, as we see, this is the one we ran last time. I go in this way. It is a trace route we want, and now it's just the second time we run again after doing the OSPF neighborhood changing. And okay, it changes like this. Change. And what the reason for that? What the reason for that? Yeah, in this network topology, when we do the troubleshooting, we focus on the neighborhood, the OSPF neighborhood. Here, the OSPF neighborhood change information are recorded here. From this, we can find the reason why the trace route change. Okay, and this is the information. From beginning, it is empty and the information is just written in after executing the code 2 times. This is the first time. It just shows a network um, uh, neighborhood status. There's no problem. No problem. This is the second time. Sorry. Yeah, this is the second time. We will see whether there's a problem. Yeah, look here. I just listed the problem. This is one we change manually. Okay, for the scene 3 beside. Okay, for the scene 3 beside, and then the 0/1 fail to have established. And is there something wrong with the configuration? Oh no, it should be okay. Have a look. Okay, 0/0 in beside C beside 4. Okay, fail to establish the neighborhood. Oh, we see. Yeah, there's no SPF setting under under the series, under the interface. This is the reason we find because yeah, the neighborhood, the OSPF neighborhood down. So it find the issue and record in the file. To know the issue, we can change it back. We go to the okay, let's say the 0/0 down 0/0. And then there's no OSPF setting under the interface. Um, we check it back. Okay. Yeah. OSPF neighborhood recovery, and then we run the code again. Yeah. Uh, as I say, the code is written according to the traffic flow. It's written according to the idea for doing troubleshooting for this network topology. Yes, here for this network topology, and the main reason for crystal changing is OSPF neighborhood change. Or that's to say, we can't learn the one destination address from a fixed route because some OSPF neighborhood down or change down. Uh, yeah, so the code mainly focus on monitoring the involved devices for a pin connection and see whether there's OSPF neighborhood change, whether there's change for OSPF configure, and record the change in the file. This is the principle I do troubleshooting. It can monitor all the OSPF change and cover the network in this way. Okay, it's done. So we see the file again. This time we do it. This time we do it. Okay, I get recovery. Yeah, I get recovery. See, get recovery. You get recovery. Yeah, it's still now. I go to the cine beside 1 in this way. 3 cine beside 4 and 1. Yeah, if we see the information here, we can see this latest one, and there's no, yeah, just list the OSPF neighborhood, but no interface. Just down the OSPF neighborhood connection. This is the principle I do the troubleshooting. This is okay. If a pin there's no there's no address like 1.1.1.1. There's no address in this interface in this network here. So if we try to pin this address, I will say no, I can't pin. For example, if we try to pin this, I will say no. Yeah, I will, yeah, and run the code to do this. You say from A7 here into 1.1.1.1. As I say, it will take time. Yeah, unsuccessful. I take time for the code running. Yeah, and you can do something else. One, I do the troubleshooting automatically, and you can also just run several codes in several uh, in several computer and on several VMware machine to do the troubleshooting, just to do the different troubleshooting at the same time. In that to say, you can deal with the multiple troubleshooting tickets at the same time. One person can do multiple tasks at one time. This is a yeah. This is a code. This is a code. What's up? What's wrong with that? Something. Okay, the reason is in this in the real project will not have this issue because as I say this you have to range the PC have a static route to all the to all the to all the network device. If not, and there's and you can't have the exclusive pin connection to each network device, and if there's a root issue, it will affect your PC connection to the network devices and affect the telnet login, device login, and will have some issue. So have a static root to each devices. But anyway, we know, it's unsuccessful to pin 1.1.1. Um, this is the program. I write about the troubleshooting automation, and yeah, uh, I try to explain this program again, just a little bit more. It asks you to write the device, the source device, and the destination address, and there, just and work according to this. There are some files coming with the code. Um, okay, I think a little bit more. I try to close and explain the code a little bit. This is the interface IP. Is a name. Uh, I just include all the IP address in the just the network device. Uh, as I say, the first thing the program do is just it translates the source device to the IP address. It just there's a translate form. You input the name of the source device, it translate to the IP address, and log into the device and do the operation. And you apart just input getting the source device name, and you also input the destination IP address. So the program gets the source device and the destination IP address, and then it just know, okay, which pin you want to do, from where to where. And for each pin connection, there's a preferred trace route, and the information is recorded. It's recorded in the inventory file. And the computer will just the code will go to this file and check. Okay, the inventory information. For example, in the example we show in this video, we go to from Mohill 7R7 to CNIP 1. The preferred the preferred the preferred route is this one, and according to this trace route, I will just do the monitoring and the troubleshooting. I will monitor the OSPF neighbor change and monitor OSPF configure change. Focus just about these devices involved in this row trace, a trace route. And if there's some change, we record in the file here. Just like we once change the neighborhood and make the trace route change, so it's record. Sorry. Yeah. Okay. We'll just list the neighborhood and find whether some device, some interface fail to have just establish neighborhood with the neighboring with the connection devices. If there is, at least the interface name. This is the troubleshooting. Done. Okay, the trace route is recorded here with the current time running the code. Okay, this is the as this is an example of network as troubleshooting or automation. As I say, the automation code for troubleshooting or the configuration updating is written according to the network traffic flow. Yes, so it is just an example to just show you the idea that we can do the just the network operation, mainly about just the troubleshooting according to the do the automation troubleshooting or writing program. In this way, we can save time, and we will not go device by device. For example, here, if we want to find the issue, okay, here, as I say, I used to close the neighborhood in the if there is some reason and the neighborhood close and we want to fix the issue, we have to go device by device and we just use the show command to see, and it's boring and take time. And by running the code, we can make computer to do this, and we save time to do something else, or even we run several a code, we run the code in different computer to deal with the troubleshooting task at the same time. This is a network automation example I want to show you. Hopefully, it can helpful for you to develop your automation code and enhance the working efficiency in your work. Thank you for watching. I think this is all for this video. Thank you for watching.